Hello everyone, in this video, we will discuss free space management. The storage space is limited, so we need to use the storage space efficiently. The file system keeps track of all free disk space to maintain a free space list. The free space list records all free device blocks. The free blocks means the blocks that are not allocated to files or directories. To create a new file, we search the free space list for the required amount of space and allocate that space to the new file. That space is then removed from the free space list. When a file is deleted, this space is released by the file. So this space is added to the free space list. The free space list is not necessarily implemented as a list. Now we will discuss two different ways to implement free space list. The first one is a bit vector or bitmap. So the free space list is implemented as a bitmap or bit vector. Each block is represented by 1 bit. If the block is free, the corresponding bit is 1. 1 means this is a free block. If the block is allocated, is occupied or used by a file or directory, the corresponding bit is 0. So now the block 0 is free and the block 1 is allocated. Block 2 is free and block 3 is free and block 4 is allocated. So this is called the bitmap or the bit vector. Another approach to free space management is linked list. The linked list link together all free disk blocks. Okay. Link together all the free blocks and keeping a pointer to the first free block. Each block contains a pointer pointing to the next free block. Now, here we have an example. The free space list head is a pointer point to the first free block. Now the first free block is a block 2. And in the block 2, the block 2 contains a pointer pointing to the next free block. This pointer points to the block 3. So now in this example, the first free block is block 2. And then the next free block is block 3. The block 3 contains a pointer to the next free block. It's a block 4. And now the block 4 contains a pointer to the next free block, block 5. And block 5 has a pointer point to block 8. Now 8, there is a pointer pointed to the block 9, and then block 10, block 11. So these are all free blocks. 10 and 11, and then 12, block 12 is free block, and then the block 13, and then the block 17, block 17. And then we have the block 18, block 25, 26, 27. 18 and 25, 26, and 27. Now the 27, in the 27 contain the null points, means 27 is the last free block in this example. The linked list, when we use a linked list to organize the free blocks, it's not easy to get the contiguous space. Now the way, for example, we want to get the 7 free blocks, the contiguous free blocks. So we need to traverse all the entire free space list to see if they're contiguous. And also use a linked list to implement the free space list. It's not efficient to traverse the list. So we must read each block and get the address of the next block. But fortunately, traversing the free list is not a frequent action. Normally, we don't traverse the entire linked list to get all the free blocks. Usually the operating system simply needs a free block so that it can allocate that block to a file. So the first block in the free list is used. Okay, this is how we manage the free space blocks. This is all about the file system.